Hey guys, welcome back here. We're going to continue our radicals here. What we're going to talk about now is we're going to talk about radicals that have variables, okay? So before we go over these four examples I have here, let me just talk about, so for instance, if you had the square root of 49, right? That would be 7 times 7. And we know the square root of 49 is 7, right? Same if it was 100, right? Square root of 100 means there's two tens, right? Square root of 100 is 10. Now, if I replaced the number with a variable, all right? So let's talk about x squared. So x squared means there are two x's, right? So anytime you have a group of two, one is going to come out of the radical, okay? Now you'll notice there's nothing left inside because there's a group of two. So the answer to this would just be x. So let's say we had x to the fourth. Well, if we just wrote it out the long way, how many groups of two do we have? We have two groups of two. So that means two x's would come out of the radical, and you would be left with x squared. That means two x's. Okay? Now, one other thing. What if there was an odd amount of variables? All right. So let's say there were 7 x's under there. So if I wrote it the long way, 1, 2, 3, 4, 5, 6, 7 x's, right? 1, 2, 3, 4, 5, 6, 7. How many groups of 2 do we have? We have 1, 2, 3 groups of 2. So that would be x to the third, but we have one left over, kind of like a remainder. So that one is going to stay under the radical bar. All right. So basically what you're doing with variables is you're just dividing it by 2. So if you have an even number, all of them will come out. If you have an odd number, you'll always have one left over. All right. Let's go ahead and tackle these four problems here. So if you go back to our simplifying rule, remember we have the perfect squares. Guys, also on the notes, I would like you to write out the notes so you could have them available while you're doing the homework or the classwork. All right? So if you have your notes available, you could print them out or write them on a piece of paper if you don't have a printer. All right. So again, what I like to do is I like to make a list of perfect squares. Those are numbers that are going to go inside of here. So anytime I'm doing a square root, I always start off with 4, which is basically 2 times 2. So we got 4, right? Okay. So the next one would be 3 times 3 is 9, 16, 25, 36, 49. I think that's going to do it. These numbers are kind of small. So our job is to find out, we're going to break down the radical again like we did before, and have something a little extra do is do the variable. All right, so let's start with the first one. We have 72. Well, which one of these numbers go into 72? Evenly, that answer is going to be 36 times 2, right? And then we have 3 x's, right? Let's deal with the number first, and then we'll talk about the variable. Okay? So the 36 is going to come out as a 6. And then you're going to multiply these two, right? Remember, if there's a number already out, so that would be negative 42. Now let's deal with the letters then. Now remember, we still have the 2 left over because we took the 36 out. How many groups of 2 can we get? Well, there's only one, right? So we're going to take that out. Always put it in front of the coefficient. And in this case, we got a remainder or 1 left over. So that would be my final answer. Okay? Let's try the next one. All right, we got negative 3 on the outside. We're going to break down 75. Which one of these numbers go into it would be 25 and 3. And then we have 4 m's, right? All right, square root of 25 is 5, so that'll be negative 3 times 5, which is going to be negative 15. Okay, 25's gone, right? We've got 3 left over. Now let's deal with the letters. We have 1, 2 groups of m, so that would be m to the second. Okay. If you want to pause the video, I will give you a moment. And then you could try number 3 and 4. All right. All right, let's take a look at 3. So we're going to break down 24. So which one of these numbers go into 24? 4, right? So it's going to be 4 times 6. And we've got 3. And you don't have to write out the letters if you don't want to. Remember, we're just dividing them by 2. Okay? All right, what comes out? The perfect square. So we got 2. I'm going to leave a little room because I got some letters to put there. 6 stays in because nothing else up here goes into 6. All right, how many groups of x? Well, I got 1 group of x here, so that's going to come out. And we have 1 left over. And then here we've got 1 group of y, 2 groups of y. So we have y2, or 2 y's. We're done. Okay. Now the last one. 6. You've got 36. Ooh, 36. Well, that is a perfect square, isn't it? You got 4 x's. You got 1 y. And you got 3 z's. Okay? So again, we're looking for groups of 2. Well, you'll notice the 36 can just be broken down because the square root of 36 is 6. So the whole thing is going to come out, right? Because there's nothing left over. Okay. So 6 times 6 is 36. Now let's deal with the letters, right? All right, how many groups of 2 can we get from the x's? Well, if there's 4, we could get 2 groups of x's, right? There's only 1 y. Remember, you need 2, so the y is going to stay in. And then you could get 1 group of z's, so a group of 2 will come out. 1 stays in. And then that's my final answer for the variables. Okay? So variables are hopefully not too difficult. Again, you're looking for groups of 2.